This is topic 4.1 on plate tectonics for AP Environmental Science. So our learning targets and learning goals are here at the top. The first thing to learn about is the layers of the Earth. You have three main layers: the core, you have the mantle, which is liquid. The core is solid, made out of iron. The mantle is liquid, but kind of thick liquidy. Think of lava underground. It's made out of magma. And the upper part of the mantle is called the asthenosphere. And then you have the lithosphere, which part of the lithosphere is the crust, and that's what we are on. It's basically the surface of the Earth, whether it's on land or under the water, whatever the surface layer is, that is called the crust, which is part of the lithosphere. So here's our descriptions of these things, what the core is, what the mantle is, what the lithosphere is. Now, you don't necessarily need to memorize those terms there's not going to be a vocab question on these terms, but you do need to understand these terms to understand how plate tectonics work and how the core is really hot and it makes convection currents, which are currents that rise and fall with temperature of the magma inside of the mantle, inside of the asthenosphere. So knowing the layers of the Earth help you understand the next part that you do have to know for the AP test. Let's talk about plate tectonics. Hopefully you've learned about plate tectonics in a previous science class. It's taught, at least in my community, it's taught in 6th grade. It's also taught in our chemistry classes. You don't have to know the background of how it was discovered by Alfred Wegener and his hypotheses, but basically he hypothesized that the continents all fit together at one time, and the full crust of the Earth is broken up into pieces, which he called plate tectonics, or called them plates. So it's like puzzle pieces. We call them plates. So you may have learned in a previous class about there's a couple of supercontinents like Pangea, where the continents all fit together at one time. It's the reason why we have fossils that are the same species on different continents, because way back millions of years ago they were together. So here's our current understanding of how the plates work. All of these little jagged lines here are the boundaries. And so here in where I live, in near the Los Angeles area, we're on the Pacific plate. You can see the name of it here. It's a really, really big plate here. And if you live, for example, in Washington State, you live next to the Juan de Fuca plate. Just about 20 miles to the east of where I live, you cross over the plate boundary, which is called the San Andreas Fault, and you're on the North American plate. So most of the United States is on the North American plate, including San Francisco. San Francisco is actually on the North American plate, and Los Angeles is on the Pacific plate. Interesting facts. Okay, so there's just a few plate boundaries that you need to know, and we'll talk about those later. But we've broken up, well, not we as humans, we've discovered that the crust of the Earth is broken up into these different plates. Okay, so plates get stuck. They really want to move a few centimeters on average a year. They're being moved underground by hot magma. We'll talk about that in a second. But the plates get stuck, and so this is what causes an earthquake. So really the ground should be constantly moving, very slowly, but it doesn't. It gets stuck. So the ground tries to move, it gets stuck, and pressure builds up. And then when the pressure finally releases and the crusts move a lot at once, that's called an earthquake. And so you do need to know this first bullet point for my test, for the AP test. What causes an earthquake? What happens between earthquakes? And so the plates get stuck and the pressure builds up. Now, earthquakes are measured on the Richter scale. Each point on the Richter scale is actually 10 times stronger. So for example, I lived through the 94 Northridge earthquake. I was in college at the time. It was a 7 on the Richter scale, which is 10 times as strong as a 6 on the Richter scale. So that's kind of how that goes. All right, so sometimes in the middle of a plate, like in the middle of the Pacific plate, you have magma that comes out through a crack. We call that a hot spot. And so there's a fissure. Fissure is another word for a crack or a dividing or an opening. And so magma comes out. Now, first it's going to hit cold ocean water and it's going to turn into crust underwater. And then that's called a seamount. And then as more and more lava is when magma comes out of the crust. So more and more lava hardens, the underwater seamount gets taller and taller and taller, and then eventually it breaks the surface of the water and it builds an island. So underwater, it's called a seamount. Once it breaks the surface and gets into the air, it's called an island. So there's many hot spots around. There's several in the Pacific Ocean. There's one that specifically creates the Hawaiian island chain and some of the others out there. And then there's other hot spots that have created like the Tahiti island chains, they're called the Society Islands that Tahiti's part of. Okay. You also need to know that a tsunami is displacement of water. So when you do have an earthquake, it can make the water move and that can cause a tsunami. So if you're ever at the ocean and you feel an earthquake, get to high ground immediately. Run as fast as you can to get to high ground immediately. All right, so there are 3 types of plate boundaries. We have divergent, convergent, and transform plate boundaries. So divergent boundaries, diverge means to split apart, and so divergent plate boundaries pull apart. Usually happens underwater. It happens on land in a couple of places. We'll talk about those in a second. So it mostly happens under the oceans, and we call it seafloor spreading. So you need to know divergent boundaries pull apart. The results are usually seafloor spreading, where magma comes out and forms new oceanic crust. There can be volcanoes, earthquakes, something called a rift valley under there. This is a picture. So you can see here, these arrows are pulling apart and then magma comes up and out to fill here. And it cools off and you have this underwater mountain range that's being created by this magma. So that's a divergent boundary. Okay, next one is convergent, and we have 3 main types of convergent boundaries. First of all, we have 2 types of crust. We have continental crust and we have oceanic crust. Continental crust is made out of granite. Oceanic crust is made out of basalt. Okay, convergent boundary is when 2 come together, and there's 3 things that can happen when 2 plates are pushing against each other. When one plate is heavier, more dense, one subducts below the other. So subduction is when one plate goes beneath the other plate. And usually it's the oceanic one that's heavier with basalt, but sometimes it's 2 oceanic plates that come together and they're both made out of basalt. And so it's actually the older one that's heavier because sediments have fallen on top of it, and so its mass is higher, therefore its density is higher. So the older one will subduct below the newer crust. All right, so the other type, well, first of all, anytime you have continental and oceanic, the oceanic will subduct below. When you have 2 oceanic plates collide, the older one will subduct, and on the other plate, you end up with islands that are formed, and it creates what's called an island arc. Sometimes it's called a volcanic island arc. And then when you have 2 plates, 2 continental crusts that are the same density that push against each other, they actually push up and form mountains, and that's like the Himalayas, and you can see that in this picture here. Okay, a transform plate boundary is the one near me, the San Andreas Fault, which is, this is the picture of. So I live kind of right here, and just to the east, about 20 miles away, people live on the North American plate. And so it actually slides past each other. It's called a transform plate boundary. It's also called a slip strike fault. Okay, so you can see the 3 here: divergence pulling apart, convergence coming together, transform is sliding past. Okay, so what does this all mean? So species are forced to adapt. Now, this has changed over long periods of time as plates move. A plate could be near the equator and nice and warm, and then moves toward the poles and becomes cooler again over millions of years. So species will change. Most of the species that have ever been alive are extinct on the Earth. So here's our plates again, and you can see there's different types of plate boundaries. So we have different symbols down here about if it's spreading. So the seafloor spreading apart, that's in orange here. There is something called the Mid-Atlantic Ridge. Watch my cursor. It goes down the middle of the Atlantic Ocean, and so the Atlantic Ocean is splitting apart that way. The Pacific Ocean is mostly one big plate, and it splits apart in certain parts of the area. You also have a lot of subduction zone, which leads to a lot of earthquakes and tsunamis in the Pacific Ocean. They don't really have tsunamis like in the Atlantic Ocean like they do in the Pacific. All right, so you do need to know that volcanoes, island arcs, earthquakes, hotspots, faults are the result of plate boundaries. All around the Pacific Ocean is called the Ring of Fire due to all the tectonic activities. And the Ring of Fire means volcanoes and lava, but it's also earthquakes and things like that. All right, going on. You can see here that these are the locations of earthquakes. And so that is in gray down here on our key. And you can see massive amounts of earthquake all along these areas, including where I live in California, all the way up Oregon, Washington, Alaska, Japan, Indonesia. Lots and lots of earthquakes in these places. Not so much if you live in the eastern coast here of the United States. All right, so there's a few main areas that you need to know for the AP test in terms of plate locations. You do need to know the Mid-Atlantic Ridge goes down the middle and it's divergent, it's splitting apart. You can see that on land in Iceland, so you can actually see the Mid-Atlantic Ridge on land in Iceland. You can also see plates pulling apart here in Africa with the African Rift Valley. So it's the same thing. I didn't draw a line here. I just put a dot telling you need to know that. Okay, you need to know the Himalayas. The Himalayas is convergent, where the mountains are pushing up and creating taller and taller mountains. So Mount Everest, which is the tallest mountain in the world, is getting taller due to this process. You need to know in Japan, they have a subduction zone where one oceanic crust goes beneath the other, causes earthquakes and tsunamis. You need to know in the middle of the Pacific Ocean, we have our Hawaii hotspot that has built the Hawaiian island chain and many other islands. In the middle of the North American plain, we have the Yellowstone hotspot. It's why Yellowstone National Park is very geothermically active. The San Andreas Fault runs through California. It divides the Pacific and the North American plate. Up in Oregon and Washington, you have a subduction zone that puts that area at deep risk of earthquake and tsunami. And then up here in the Aleutian Islands, which is actually off of this picture, but it kind of extends here where this dot is. You have a volcano island arc very similar to Japan up in Alaska. All right, so that is it for topic 4.1.